This is a review of correlation and causation, as you can see from the document here. And I will put this document in PDF form on Edline along with the video. So what are they talking about here? Researchers want to find out if there is an association between math anxiety level and performance on a math test. So 24 students volunteer for a study, and they're interviewed before the math test, as you can read here, and their anxiety levels are assessed 1 to 10. And then beside the anxiety level is their score on the math test. So the first thing we're supposed to do is enter the data in the calculator and make a scatter plot. So here's the data. I'll scroll down so you can see all of it, because we're going to see, is there an association between the anxiety level and the math test. So ignore student number. That does not go into the calculator at all. What's going to go in L1 are going to go the anxiety levels, and in L2 are going to go the math tests. And you can see over here on the calculator, I've put everything in to L1 and L2. You can stop this for a second and put these numbers into your calculator, and then resume when you have that done. Now, what is how do we make a scatter plot? We're going to do second and y equals. I've got the residuals here. So you're going to hit enter to turn it on, and then arrow down, and make sure that L1 is the X list and L2 is the Y list. And you want to make sure that your calculator is set. I'm going to go back up to type here, to the icon that's in the top row of type, furthest on the left. Now, this is histogram. This is a time plot. This is a box plot. This is a box plot without outliers. And this is a normal probability plot. This is the scatter plot, where you have two variables. All the rest of these are for one variable. So with the time plot has two variables, but the other variable is time. Okay, so X list L1, Y list L2. And then you hit zoom 9. And so there is the scatter plot. This scatter plot is negative, weak, linear. Negative, weak, and linear. Okay? So, does there appear to be an association between anxiety level and test score? Yes. There is a negative, weak, and linear association between anxiety level and test scores. There does not appear to be any unusual points, outliers or whatever, since the association is weak to begin with. Okay, so now we're going to run the data. Now, first thing we got to do, question 3 wants R. So we have to do second, and then 0 for catalog, and then hit the inverse key for the letter D, and then arrow down to diagnostic on. I went too far here. Diagnostic on, hit enter, and enter again. Okay, diagnostic is now turned on. We're going to hit stat, calc, 8, linreg. It defaults to L1 and L2. Hit enter. And we have A. This is in the form of y equals a plus bx. So A is the y-intercept. B, that's the slope, is negative 4.48 or 4.49. R squared is 0.27, we'll round it to 6, and R is 0.525, we could call it. Okay. So find the correlation R. What does the correlation indicate? Well, the correlation is negative and the correlation is weak, which confirms our perception about the scatter plot. Interpret R squared in this context. Let me scroll down here because I have some written answers to this. Okay. Number 4. R squared. 27.6% of the variation in math score is accounted for by variation in math anxiety level. It's 72.4% of the variation in math test score is accounted for by the residuals. Okay, that's the errors. That's the differences between y, the actual y values, and y hat, the estimated y values. Or the actual test scores and the estimated test scores. Okay, so what's the equation? The estimated test score equals 91.66 minus 4.49 times the anxiety level. Now question 6, here, let's go back up here. That's the linear model. Is this linear model appropriate? Well, here's the residuals plot. Well, how did I do the residuals? Let me clear this. So I did a second and y equals, I go back to my scatter plot, and I can just go down to, I want to use the x value, so I can go to L2, and if I go to second and list, I'll put in 7 for the residuals, and I hit enter, and zoom 9. Okay, now here's my residuals. All right, I did these residuals here on the y value, on the y with the variables reversed. But it doesn't make any difference. They have the same plot. So just this one's a little more spread. The one on the right here is more spread out. Okay, but the residuals of this is x versus the residuals. This is the residuals versus x. Doesn't make it, it's the same thing. The residuals versus x values is random. The linear model is appropriate, assuming other preconditions are met, which we're not going to go into right now. Okay. Question number 7, interpret the slope. Okay, now the slope. Let's go back here. 91.66 is the y-intercept. Okay, that's A. B is the slope. It's negative 4.49. R squared is R squared, and R is the correlation. Now let's go down. Okay. Slope equals negative 4.49. For each increase of 1 on the math anxiety level, the expected math score decreases by 4.49. Okay, the next question is, what is the meaning of, how do they put it, the y-intercept? Okay, and that's A. If the math anxiety level equals 0, then the expected math score is 91.66. Last question. Does this prove that anxiety interferes with student performance? Correlation does not establish causation. That was our little mantra from the first semester. The anxiety level in math test score association could be due to some third unknown variable, aside from the fact that the correlation is weak to begin with. And I'll add here, causation, only a controlled experiment can establish causation. Okay, and that's that.